Not only is the k method used for equations where we have rational exponents of x, but it's also used for equations similar to the one on the screen where we have repeated terms. So the first step is to identify the terms that are repeated. In this case, it is x squared minus 2x as it appears as the first term and the denominator of the second term. So why is this significant? That is what you let k equal to. So we start off by saying k is equal to x squared minus 2x. We now replace those terms with k, so we have k minus 3 over k is equal to 2. Now remember that the whole aim of the k method is that you want to take an equation that is not in quadratic format and get it in quadratic format. That would be ax squared plus bx plus c. But in this case, our variable is going to be k. So how we would get that is we need to multiply throughout by k so that this k in the denominator can be removed. Multiplying throughout by k, we have k squared minus 3 is equal to 2k. The next step is to take the 2k over to the left-hand side. It becomes negative 2k, and we now have a 0 on the right-hand side. Bear in mind, this is now in standard quadratic format. So the next step would be to factorize so that we can solve for k. Remember, how we go about doing this is we will have two brackets. Each bracket will contain a binomial. We have k squared, so each bracket gets k and k. We now look at factors of the last term. When we multiply them, they must give us negative 3, but when we add them, they must give us negative 2. Factors of 3 would be 1 and 3, since it is a prime number. And the sign manipulation, we should have a positive 1 and a negative 3. So if we just check this out, positive 1 times negative 3 gives you negative 3, and 1 minus 3 gives you negative 2. Solving for k from the first bracket, we have k is equal to negative 1, or k is equal to positive 3. However, bear in mind that the initial question given did not have k in it. We just introduced k as a means of getting this in standard quadratic format so that it can be solved. Since our initial equation had x in it, the next step would be to replace k with what we had equated it to. So we had k is equal to x squared minus 2x. Let's replace k with that. So x squared minus 2x equals negative 1. And here we have x squared minus 2x is equal to 3. Now looking at these two equations, we can get them in quadratic format if we take those constants that are on the right-hand side over to the left. By doing so, this is what we end up with. Now at this point, we would need to factorize each trinomial separately. Working with the first equation, we would have x and x in each bracket. Factors of 1 would be 1 and 1. We need the signs such that when we multiply them, they give us positive 1, but when we add them, they give us negative 2. We would need both 1's to be negative. Solving for x, since both brackets are the same, we write the answer out once. We have x is equal to 1 as our first answer. In the second equation, we're going to factorize by opening up two brackets. We have x and x. We need factors of 3, which is 1 and 3. And the sign manipulation would be a positive 1 and a negative 3. Positive 1 times negative 3 gives you negative 3. 1 minus 3 gives you negative 2. When we solve for x here, we end up with x is equal to negative 1, or x is equal to 3. So those are our answers.